These are in listen-only mode.
Hello everyone, and welcome to the webinar. This is Sydney speaking, and today's webinar we'll be talking about HSR and HSS, actually. Not HSM like people would think I would be talking about, but I'm actually talking about HSR and HSS. Now, we'll be doing a lot more than just talking about the part. We'll actually be programming the entire part from beginning to the end. What I mean by an entire part means including creating the home position, the stock, putting in the fixture, doing the machine setup for the fixture, and then doing all the operations. Now, in this particular part that we see on our screen, what I'm going to do is, as I said, program the entire part, and you'll see that I'll be using in this on this part, I'll be using certain 2.5D operations such as face mill. I'll be doing some pocket operations here as well. I'll be doing HSR to remove all of the rough material that's on the part itself, and we'll show you some options that we have there as well to help me remove the material as most efficiently that I possibly can. And we'll be doing HSS in areas where the 2.5D operations can't do the job that we need to get done. Now, as usual, we will have time for questions at the end. And if you have any questions, all you have to do is click on where it says raise hand. And in the questions area, just write down your question. And when you finish writing down your question, don't forget to click on the send button so that I can actually receive the question. And at the end, I'll go through all the questions and try to answer them to the best of my ability. Okay, so let's get started now with the webinar itself. And as I said, we're going to be starting off with this part as shown on the screen. And as you can see, the part, it's just basically a part with one that has to be machined from one direction, only from the top over here. There's nothing to be really done on the side. But as you can see also, there's this area over here, which is really a simple pocket area of itself. And we have a regular profile on the outside. But you'll note that we have areas such as this over here. And also symmetrically on the other side as well, areas that need to be really done using HSS. Now, besides with the part having this part itself, I also be using a fixture, or I should say I'll be using a vise that looks like this. This is the vise I'll be using, and I'll be putting that into my setup as we go further on in the part itself. Okay, so let's get the part back on our screen, and let's actually start our process. Now, I've created this part already with a configuration of stock as shown over here, and I actually liked working with configuration stock rather than automatic stock, because this way I can make my vise associative to this stock itself. Okay, let's start by going to SolidCAM, new milling. And as you can see, we've opened up the windows, and you can see this is the part that we'll be using. And I'll just click on OK to start the process. I have my machine here, and I'll be creating a home position. And in this particular case, I'm going to click on the top, and my home position on purpose, I'm keeping it at the corner of the part. Normally when I do the webinars, everyone always sees me put the home position in the middle. This time I want to actually put it at the end, and to show that it can be done this way as well. Okay, my home position is over here. We're all set over there. And that's all I need is just this one home position. And we're done with that. Next thing I like to do is create my stock. Excuse me. So I'll go into stock. And since I have it as a 3D model, I'll just change my define by from box to 3D model. And I'll change my configuration to my stock. And just click on that to get my stock defined. If I click on show, you can see that that is my actual stock, as we'll see during our simulation. Okay, we're all set. My target I don't have to do because in my settings of SolidCAM, I have it set already that my target is done automatically. If I were to click on this, you'll see that my target has already been picked, so I don't really have to do anything over there. That's all done. Okay, so we're basically set from this point on. Now, next thing I'd like to do is put my fixture in. So I'll change my configuration to stock so that we can see the stock itself. Plus, I'll bring in my fixture, which is my vise. So I'll go to assembly and I'll do insert component. Now, since my vise is already open, it appears in the list over here, and I'll just put it down over here. Now, in this particular case, I already did homework and I checked that the length, this area, the width of the stock itself is the same as the distance between this surface over here and this surface over here. They're both the same length. I did my homework and I checked it out. And in case it wasn't, all I really have to do, in this particular case, I would say with this vise that I have over here, we just go into my tree, open up my vise, the entire assembly over here. And in this particular case, I have it as a mated, in my mates, I have my measurement over here. All I had to do was change that and everything will be set exactly according to the length the width that I have over here. But this is all set, all good and well. Now let's just do some mates. I'll click on mate and I'll start off by clicking on the bottom surface over here where I want the stock to sit on, and I'll click on the bottom surface of the stock, and as you can see, it's coincident over there. Next, I'll click on this side of the stock together with this side of my vise, and that's coincident over there as well. Now, I'd like to have my vise, sorry, let's undo that. Let's do undo. There we go. Let's start this again. I made a little mistake of my own. I'm only human. Okay. Let's do file. Let's do mate. Sorry, my mistake again. We'll do, there we go. Insert component. We'll do browse. I have my vise over here. All set. And we'll just go this quickly. I'll do my mating. This to this surface over here. I'll do this surface to this surface over here. And since I want this sitting in the middle, I have a, I like working where I have surfaces already, planes already in the middle of my part and in the middle of the vise. So all I have to do is match those planes. So in this particular case, my long vise, I'll take my front surface as shown over here, and in my cam part, in my design model, I'll take this surface, there we go, this surface which goes through the middle over there, and we're all set. We're all mated up as far as that goes. Now, one more thing I like to do that'll help me out a little later on. Note my home position is in the corner over here. I'd like to actually make a little bit of a sketch over here. And in my sketch, what I'll do is I'll just put a point exactly in the middle of the part. And I'm going to use that for further reference a little later on. Okay. Now, since I've mated my vise to my stock, I also want to have this in the same configuration, so this way when I turn off my stock configuration, I won't get any errors from SolidWorks as far as the vise itself goes. So I'm going to go into my tree and I'll open up, I'll right click on my vise, and I'll just go into configure components, and in my standard mode, I'm just going to suppress my vise. So now if I go into my configurations, I go into standard, you see we have no vise. With the stock there, the vise is available. Okay, Now let's go and do our machine setup. Now we have to define our fixture first, but normally I would do this going to fixture and creating and defining the fixture, but we can also do this inside the option of machine setup. So I'll right click on operation, go directly to machine setup. And as you see over here, we have here where it says fixture and it says none. But if I click in this area and click on the arrow, I can actually go to define a fixture at this point over here. Now, to define this fixture, since it's an assembly, it has several different components in it. Instead of clicking on each one of the components, I'm going to use the option of CAD selection to make it a little easier for me. And in CAD selection, I'll just go into my CAD tree and click on the vise itself and then click on resume, as if I picked the entire vise assembly. And now I'll just click on resume. Note that all of the components are now listed in my fixture. If I click on show, you'll be able to see that everything was chosen over here, and we'll just accept that. Okay. Now what we have to do is set our X, Y, and Z towards the machine. Now, X and Y cannot be 0 because 0 would make the home position exactly in the center of the machine. I want the center of the part to be in the center. So if you remember, I created that little point exactly in the center of the part itself, and I'm going to use that to my advantage now. I'll just right click on over here on X, and I'll choose pick X, Y, Z. And all I'll do is just click on that point itself and accept that. So right now my X and Y are correct. I still need, however, my Z, because my Z is really at the bottom. So I'll just right click here, pick Z, and just pick on any edge of the bottom of the vise itself, and that's all set. And as you can see, we get the dimensions that we need here automatically. Okay, now I'm ready to start working. Okay, the first thing I'd like to do is to do a face mill operation along the top of the part itself. Now, remember the width of the stock itself is 174 millimeters. So we're going to start by doing a SolidCAM operation of face. When I go into my geometry, and I'll go to base geometry, since I'm using a model, I can click on the arrow and I have my stock here. And that's exactly where I want my borders to be based on, my stock. Okay. Our geometry is done. Next tool. Now, the way I like to work is that my machine is already attached to a tool table. So when I go into select, I have already a list of all different types of tools that I work with very often. And in this particular case, I want to start off with a face mill over here. So I'll choose the bigger face mill that I have, the 125 millimeter face mill. That's the biggest one I have. Okay, I'll click on select. Now, obviously, 125 millimeters is not big enough to do this in one pass. So we're going to be working on this in a hatch fashion over the part itself. Okay, our levels. My upper level will be the top surface as shown over there, and my face depth will be up until this surface over here of the part. I'll just click on the corner. This way it's associative to the part itself. And now let's go into our technology field. In our technology field, what we have here is as follows. First of all, we have hatch, which is the way I want to work. Now, we also have our floor offset. I'm going to actually leave a bit of a floor offset of 0.2 millimeters and do a finish. This way we have a nice smooth finish on the floor itself. Next, we have our overlap. Now, I don't want to have a 30% overlap. That's kind of a large amount. If I go into value, all I really want to have is just a 10 millimeter overlap of the tool itself. That's fine. Now let's actually go into the parameters of hatch itself. I'm going to leave everything the way it is except for one thing, my cutting direction. I would like to work one way over the part. Perfectly acceptable. That's the way I prefer. If you prefer a zigzag, it's fine, but I prefer one way, going always in one direction. Let's save that and run my simulation. And let me run my simulation at this moment, just this time, using machine simulation. Now, the reason why I'm doing this right now in the machine simulation is just to show you that the way I picked my my machine setup, the way I did my machine setup, you'll actually see the fixture and part sitting exactly in the middle of the table itself, exactly where I needed to be. All right, so we'll start our simulation. You can see the tool goes down one direction, goes back up, then goes down again in one direction, and now it finished off everything over here. Okay, that was my first operation. Now I'd like to continue on the part, and on the part now I'd like to deal away with all of the excess material that's here. Now let's basically do a rough cut. The quickest way for me to do it right now is by using HSR, and we'll see exactly the options I'm going to be using in order to do this in HSR. So we'll do 3D HSR, click on that. I'm going to use the option of HM roughing. With HM roughing, this is actually probably the best way to do a part where you have both outside and inside areas, pocketed areas, and also we have cavities and core areas on that part itself. Okay, so we have our target, our tool. I like to use a tool over here. Now, what I'd like to do actually is, you see I have a whole list of all different types of tools, and sometimes it gets a little difficult to look at. So what I'd like to do is just to see only my end mills. So I'll just click on this area over here where the user defined tools, and I'll get rid of everything, and all I want to see are just end mills. If I click on OK, now we see the list of all the different end mills I have. And I actually want to start off with my 16 millimeter end mill that I have over here. Note all of my tools have holders. I like to work making sure they have holders so we can see the simulation correctly. And I'll click on select. Now, I'll also click on calculate minimum tool length. What that will do is later on, after I do the calculation, it'll show me what's the minimum tool length that I actually need for this operation. As you can see right now, I'm out of the holder 60 millimeters. Then we can compare it to see if this is enough. Okay, but let's continue now to my constraint boundaries. And in my constraint boundaries, I'm going to do this automatically according to the auto-created box of stock model. I'll click on that, and I'm going to have my boundary tool relation not centered, but I'd have that external to make sure I actually go completely outside of the part itself. Okay, next we have our passes. We'll have my wall offset. I'll leave that at 0.5 millimeters. The same thing with my floor offset. And my step down, I'm going to have that every 3 millimeters going down on the part itself. Now, as far as my step down type, I'm going to change it, instead of having constant, to have it constant plus flats. What that will do is as follows. I'm stepping down every 3 millimeters. If I have flat areas that fall in between those 3 millimeter step downs, it'll actually stop and do those flat areas as well. Okay, as we continue down, I'll be using the option of step over type, HM spiral. This is exactly good for where we have both core and cavities in a single part. Okay, let's continue now. And I'll just click on save and calculate. Let the calculation go, which will give me a quick chance to wet my throat. Excuse me. And as it's calculating, remember, it's also going to calculate the minimum tool length, which is done at the end. And we'll see the actual value that we have in there so we can compare to see if the actual tool length is correct. Let's take a look. You see the minimum tool length is set at 37. That's what it calculated it to be. And as you can see, we're out of the holder by 60 millimeters, so we have absolutely no problem working the way this tool was set. If I want, I can even go back to the tool itself, make changes over here if necessary, since this is the first tool I'm using over here. Okay, I'm just going to leave it the way it is. Let's run our simulation, and let's do actually a solid verify simulation of the part itself. You can see the fixture, the vise, and the material itself. And as you can see, it's clearing out that whole area in the middle. Then from the outside, going down to its next steps over there, and doing all of the roughing that I needed to be done. Now, am I ready to do a finish cut on this? Not really. For the simple reason that if I look at these edges over there, I went down every 3 millimeters, which is good in these areas over here because I can use the bigger step downs. But in these areas over here, if I leave this for a finish cut, this is actually a little bit too much material left for a finish cut. Now, I wasn't going to set this at a 0.5 millimeter for the entire part because that would be a waste of time. So what I'll do is as follows. I'll create a new operation by just simply clicking on Save and Copy. So we have a new operation created. And in this operation, I'll just use rest roughing. The tool, I'll actually keep the exact same tool I used before. Now, the constraint boundaries, keep it exactly the same way. The passes, I'll keep my wall offset at a 0.5 millimeter, and I'll step down. I'll even do that at 0.5 millimeters. Now, note in my edit passes, it's already set at automatically. That means it's automatically checking to see what material is left over to be machined. If I were to click on Show over here, it'll actually show me what material is left over on my screen. You'll see that in a moment. And as you can see, that's the material that's left over to be cut. Okay. My tool, like I said, is the exact same thing as before. Passes, links, everything is all set. Let's just do Save and Calculate. And as it does all the calculation over here, again, when we finish the calculation, we'll run our simulation, and what you'll see in this simulation is actually only the material that has to be cut will be cut. Okay, let's run our simulation. Solid verify. And as you see, it'll only work in the areas where it needs to work. None of the other areas will be touched. Just this area over here, the flip side over here, and these areas over here. Those are the only areas where this is being machined. Okay, if I were to do this using my HostCAD simulation, let's actually put this in the middle. You can see the tool path is only being created in these areas over here and on those areas over here. Nothing around the part and nothing inside over here except on this small area there as well. Okay, now let's start with the finishing operations. Now, let me first start with the inside area over here. And this area over here is just a simple pocket operation. So that's exactly what I'm going to do, a pocket operation. 2.5D pocket. The geometry, just like any pocket, will be a closed chain over here. Okay, by the way, since I picked my geometry over here, the depth of the actual depth of the pocket, it will be set, as you'll see later, according to the first chain part of the chain that I picked. You'll see that in a moment. Okay, the tool that I'm going to be using, again, let me select the tool, And again, let me just change this from user defined over here, get rid of all of these. And I only want to see the end mills themselves. And I'm going to use the second end mill that I have here, 16 millimeters, which I have set here for a finishing tool. I'll click on select, and I may levels. You'll note that my pocket depth is set at 22. That's because when I pick my geometry, I picked it from the bottom of that pocket, and it picked out, and it automatically takes that and puts it over here itself. I'm going to make actually a couple changes. I'm going to have my upper level on that surface over there. Since this entire area is already all machined out, and I have here only 0.5 millimeter left on the floor, I'm just going to keep that as my upper level. So my pocket depth is actually 0. If I was just to click on that surface also, you'd see that my pocket depth is actually 0. Now, it'll come down safety distance 2 millimeters before that. No problem at all. In our technology, we have our wall offset. Let's actually put it in a wall offset of 0.2 millimeters. And I'm going to click on Finish Wall. The reason why I'm doing that is very simple. When I do that, one, I can have my compensation on. And two, when I go into my link, I have my lead in available as well. So it'll actually lead in to the wall the way I want it to, say an arc, and have my lead out work the exact same way. Let's run my simulation on the part itself. Let me do it running Solid Verify. Okay. We go down over here, and as you can see, it's working on the floor itself. Goes across to the other side. Let me actually do this a little slower from the beginning. Use the top view over here if I can. Let me stop it for a moment. Get rid of the holder so we can actually see the tool. And I want to do this one step at a time. And as you can see, it's going around. Now it finished the wall to its clear offset, to its offset for the rough, and now it's actually going to arc in to the wall itself. And when the finish is coming around, it's going to arc out of the wall itself. So we have our approach, lead in, and lead out. Next, we have our outside. So let's do our profile operation for the outside. So we'll start again, 2.5D profile. We'll create our geometry. What I'm basically showing you on this part is that most of this part, in this particular case, as far as the outside and the inside goes, can be done using your regular 2.5D operations, which is exactly what I'm doing over here. I'm going to use the exact same tool I used last time. So let me go to my tools, select. And what I'm going to do, instead of, if I don't remember exactly what it was, it makes it easier if I can just use tool used in operations. Tool used in operations, I see all the tools that I've used, and picking that one is exactly what I want to do. My levels, you see I have my upper level, my profile depth, everything is over here. I can actually pick it again from the surface if I want to make it associative to the part itself. Pick that corner over there. If I want to go a touch past it, I'll go minus 0.5 millimeters. And in our technology, I'm just going to do a finish cut. But since we're going down a total of 35 millimeters, and the tool that I have has a cutting length of only 24 millimeters, so I'm going to have a step down of, say, every 18 millimeters. Now, in my links, I'm going to approach with an arc, lead out with an arc, and if we go through our simulation, you'll see that the tool will go down around the part and finish out off the outside. Okay, now let me actually go back to the part itself. And before I start my HSS operations working on these areas over here, let me actually look at this edge over here. Now, this edge over here is an actual fillet. Okay, we have this fillet over here, and we also have the exact same fillet on the outside over here. Now, honestly, I'm not going to use an HSS operation for this. I can use actually a tool that has the actual fillet that I need. In this particular case, the fillet that I need is 0.5 millimeters. So I'm going to use a tool that already has that radius for it. In other words, I'm going to be using a shape tool. So let's start my next operation, and I'm going to use a profile operation again. Now in this profile operation, note when I choose my geometry, I'm going to choose the very bottom of in other words, the very outside part of the radius itself, the lower part, the small area of the radius itself. I'll do auto constant Z. So we have my entire geometry over there. You know what? I'm going to add to this as well. Starting from this edge over here, I'll choose this edge as well. Go around the part. And just choose this edge over there, finishing that off. The reason why I'm not going on further with this edge, because this surface over there is actually not straight down, so I don't want to actually use it with this kind of a tool. That I'm going to use HSS for already. Let's do the same thing on the other side over here as well. Add a third geometry, or a third chain. We'll start over here, adding that chain over there, and whoops, there we go. And we'll go back to this side over here, click on that edge, and accept that as well. Okay, next we need our tool. Now, as I said, I'm going to be using a shape tool, which I don't have here at all. So I'm actually going to create a new tool in this particular case. As I'll go to add milling, I'll use a regular end mill. Now, before I deal with the actual diameter of the tool, let me actually choose my shape tool. I'll go to shape, and I have here tools in my table already for fillets. If I were to open this up, you can see I have 3 different fillet tools already defined over here. R2, R3, R5. I don't have R0.5. So what I'll do is, instead of creating a new tool now, all I'll do is just choose this one over here, R2, for example. Now, once I've chosen it, now it's inside this particular tool table. I'll go to Shape Edit. And in my Edit area, you can see we were talking about the torus over here, which is our first area over here. We have our top diameter over here of 10 millimeters, and then we have our radius. I'm just going to change my radius to 0.5, and note the moment I do that, my bottom diameter will be 9 millimeters over there. Okay, that's the tool I want to use. Everything's fine over there. Now let's go into my topology. Now, what's the diameter that I'm going to be putting in over here? Well, the actual diameter I'm going to write down over here is 9 millimeters. What the bottom of that radius is. For the simple reason is that since I'm working with the outside of this nose on this edge over there, I need the 9 millimeter diameter of the tool to get to that edge over there. So that's the value I'm putting in over here. As far as my cutting length, I'm going to have that, I know my tool, I'm going to have that as 15, together with my shoulder length as 15 as well. And I'll have an outside my holder of, let's say, 30 millimeters. I'll add a holder. I like working with holders, so I'll add a holder that I have over here. And that is my tool over there that I'm going to be using. You can actually see the tool if I try to get it a little closer here. You can see that there is the actual tool that I will be using. Okay, next, my levels. I have my upper level, my profile depth. Note it's already at 0.5 because I picked the edge again. I picked it from the bottom edge, which says a depth of 0.5. That's perfect. Technology, I'm just going to do a finish cut, one step, and my link, I'm going to do a link this time with a normal approach of 2 millimeters, keeping it making sure that when it gets to this area over here, it doesn't touch any of these areas by arcing out. Okay, let's run my simulation on the part itself, and I'll do this actually using my regular host CAD, and we'll take a look at the tool itself. As the tool goes down, you'll see, and let me zoom into this area itself, you'll see that the tool now is sitting exactly on that radius as shown over there. Exactly the way it should be. And that's actually going to give me the shape of the radius that I need. Okay, now that we've done that, actually let me do this while I'm here. Let me already do this using Solid Verify. You can see my tool go down, give me that radius that I need over there, as well as these edges over here. Okay, now I actually want to finish the milling of the part itself. To do that, I have to start working in these areas over here. And on this area over here, as well as these radiuses down here. For that, I'm going to actually use HSS. Okay, so let's start from the beginning of the HSS. My first HSS operation, I'll go into HSS. And I'm going to use the option of morph between two adjacent surfaces. What I'd like to do in this particular operation is as follows. My drive surfaces is going to be all the surface between here up until this area down over here. So I'll just go ahead and pick my surfaces. Let me zoom in over here. So I'll get that little one over there as well, not to forget that one. And let me just go drive along this surface over here. Get this radius over here. Pick all the surfaces that I need to work on, including this one over here, this one over there. Go further down over here. Choose that surface. And let's not forget that little one over there. Let's continue on now over here with this surface over here, this one, this one, this one, this one, and these surfaces. Those are the surfaces I want to actually machine right now. Now, let's click on Show to make sure I have all the surfaces I want to use, work on. And now my start edge surface is going to be simply picking the very top surface over here. The edges of this surface is actually touching the entire top of that area. That's exactly all I have to do. Just pick that one. Now my end edge surfaces is going to be as follows. I'll choose this one, because that's the edge it's working on over there. Go to the other side, choose this one and this one. Sorry, didn't choose it. There we go. Those are the surfaces that define my end edge. Okay, now as far as my tool goes, the tool I like to use is a ball end mill. So let me go again over here and clear all and just pick ball nose mill. I'll accept that. And I'll use the 10 millimeter ball nose that I have over here. That's fine. Let me go to my toolpath parameters, and I'm going to set my maximum step over at 0.2 millimeters. Note, I have a very small scallop over here. Okay, let me actually just run my calculation exactly the way it is, and then we'll take a look at the simulation the moment the calculation is done. Now, what you'll also see is how the scallop actually affects the tool path itself. You'll see that in a moment. Okay, let me go run my simulation, and we'll do this over here using the regular host CAD. You'll see that my simulation is over here. This is the side I picked to do it on. And note, you can see these areas over here. The steps are further apart than they are over here. That's because this is a flatter area over here a steeper area over here. And the tool can actually give you a scallop that we need with larger steps. As it gets to a shallower area, it needs more steps to give you the scallop that's needed. Okay, we'll finish off this area over here. Now, exactly what I wanted it to do, but note I really need this not only on one side, I need this on the other side here as well. This part, the way I have it, is actually symmetric. So I want to do this on the other side as well. Now I'm not going to create another operation. Instead, I'm going to continue within my HSS, go to the option we have roughing and more. In roughing and more, we have an option here called rotate and translate. I'm going to activate it. I'm going to say number of steps, total of 2, and then rotate it at 180 degrees. Now, I also have to have it rotate around the center of the part, not around my home position. So we have here rotary axis base point. And remember that point I created in the very beginning? Well, I'm going to use that to my advantage over here now. I have that point over here. I'll just click on it. So now it'll rotate exactly around that point. Let's actually run my simulation. Note the calculation now will be a lot quicker since the calculation was already done beforehand. As far as the this side over here was done. So just calculating the rotation itself. Let's take a look at the simulation. And as you see the simulation, it'll work on the first side as shown over here. And then when it finishes that side, it'll go over to the other side, doing the exact same thing. So I was able to do that without having to create another operation. Now, I'd like to continue on now with these areas over here. I want to work on this surface over here. And the same thing with on the flip side as well. So all I'm going to do is do save and copy. Now when I have save and copy, my roughing and more is still here exactly the way it is. I'm going to go to my morph between adjacent surfaces and change that to parallel to curves. In this particular case, I like to do the following. I'd like to work on this surface over here, and I'd like to work parallel to this curve over here. Parallel to that. We'll accept that. My tool, I'm going to keep the same tool. My levels, nothing to do over there. My toolpath parameters, I'm going to keep it the exact same way. And in my link, since I already know that I have a gap in my toolpath over here, I already go into my links area, and in my large gaps, I'll change that to direct. And also my slices, I'm just going to change it to blend at the very end, because there are areas where it's further away as it goes into the part itself. Let's take a look at the simulation after I run the calculation, and you'll see, there we go. You see that it does this side over here with the gaps. It actually goes directly to the other side, and since I have my rotate still there, it does both sides, even though I only defined one side over here. Now let's continue on with this part itself. And again, I'll do save and copy because I still want to do this bottom area over there. So in that case, I'm going to just use the option of morph between two boundary curves. My geometry, we'll choose a new geometry over here using this surface, this one over here, this surface over there, as well as this surface around over there, this one, that one. Just pick all the surfaces that I want to machine. Click on that surface, and one more surface over here. Those are the surfaces I want to use. We're okay with that. My start end edge will be from this edge over here, going around on this part over here, grabbing all the edges as shown over here, and completing the choosing of all the edges that I need over here, including this one, that one over there, and I do have one more edge that I still need over there. Okay, that's my start edge, and the bottom edge, my end edge, will actually be the very bottom of that. So go over here and choose this edge over here, basically doing just about the same thing I did at the top, except now we're choosing the bottom one over here instead. We'll continue on down, choosing all the edges that we need over here, as shown, and finishing off by picking this last edge over there. We'll accept that. And all I'm going to do now is run my calculation. Run my simulation, and you'll see that we're getting the exact toolpath that we need on this edge. And again, we're getting it on the other side. So basically, I've finished machining my part. There's only one thing left to do. I still have to do the holes on top over here as well. So I went this far, so let me go now all the way to the end and do the rest of the machining on the surface itself. Okay, so we'll continue with my 2.5D operation. We'll choose my drilling operation, the geometry. I'll just click on the top surface over here. So it picks all of those holes over there. Now the holes that I'm going to be drilling actually is an M6 tap. So I'm going to use the first tool I'm going to be using will be a spot drill. I can go over here and just clear all and just show my spot drill over here, which is fine. 12 millimeter spot drill is fine. My levels, my upper level is 0, and my drill depth, I'm going to actually have my drill depth not picking from the part itself, but instead I'm just going to write in a value of 0.2 millimeters to give me a little bit of a chamfer. Now, how do I control the chamfer diameter? Just by telling it what's the diameter value that I want my tool to get to at the 0.2 depth. I'm going to keep that, since the M6, I'm going to put that at 6 millimeters. Run my simulation. Let's actually do my solid verify simulation. Actually, it's doing all of the doing calculation of these areas because I didn't machine that. So just give it a moment. And what we'll actually see later on is that when we finish drilling these holes, including the taps, you'll see a little chamfer left over at the very top where the holes are, because I'm going 0.2 millimeters. My 6 millimeter diameter of that tool is going 0.2 millimeters into the part itself. So we'll have a little bit of a chamfer on those edges. Let the finish calculating the area over here. Since I didn't do my simulation over this, so I have to update it. I can cancel, but sometimes that takes a little longer even than actually doing it. So just let it go through. You know what? I will cancel. Again, we'll wait another moment until it finishes the cancellation that it does. It'll still be quicker than the other way. And while we're waiting for this to finish, I do see some answers and some questions. And one of the questions is, how did you set the depth cut in Z? Well, if we're talking about the HSR operation, then I just use the default, which is the bottom of the part itself. When I have the default over there, when I don't choose anything, it automatically defaults to the bottom of the part as is done in the part setup. If I didn't want it there, I can actually just limit it by picking the surface itself, the total depth. Okay. Now, what would happen if my total depth was at 45? Would it crash into the vise? Yes, it would crash into the vise, but you'll get a notification that you're actually, when you crash into the vise, it's showing you that you're actually crashing into the vise itself. However, in this particular case, it won't go past 35. Actually, it will, no, it will. If I actually set it at 45, it will go past it, and it will crash into the vise itself. But again, it will also tell you that. Now, as far as if I set my value past 35, does it warn me that I'm going past the area? When I click on calculate, yes, it will warn me that I'm telling you you're going past the bottom of the bottom of the part. Do you want to continue your calculation? And you can say yes or no. You can even turn that option off if you don't want it to bother you every single time. However, it does give you that warning telling you that you're going past the part itself. Okay, let me finish the calculation over here. It's almost finished over here. I shouldn't have done that, but all right, I did it. We're almost set. Okay, we just have another moment and we're almost done over here. Okay, one more moment. I see it's almost finishing. Okay, just another moment. Okay, we're almost done. Okay, there's some other questions over here. Again, you asked me about the tool. The tool will crash if you let it go, but it will let you know that it's crashing. Okay, it's not that you can make your changes if you want, but the tool will crash. Okay, let's go back to the part itself. Okay, let me run my, let me go into here and run my simulation. I'm not going to do the whole entire simulation this time. I'm just going to show you the tool actually going down into the part itself. And you can see it's going down. If I put this on the side view, you can see it's going down exactly to where it needs to go down. Let's actually do this in the wireframe so you can see it a little better. You can see it's actually, let's do it this way. Here we go. You can see it's actually going down up until the depth that needs to go down. Okay, let's put this back over here and finish the simulation. And that's all done. My next operation over here, we'll just do save and copy. I'll choose the proper tool that I need over here. In this particular case, I'm going to use a drill, a 6mm drill, a 5mm drill. Again, I have my levels. This time I drill depth. I'm going to set it all the way down to the very bottom of the hole itself. If I look into the hole, I see the actual tip of the hole itself over there. I'll just click on it, and I'm going to change my depth type to cutter tip. Now, my technology, of course, I can choose any type of. If I want to use pecking, I can use the step down. Let's say every 3mm. Let's run my simulation. And you see that the tool will go down and it's pecking into the hole itself, drilling out each and every one of the holes. And last, of course, we need to do a tapping operation. So we'll do save and copy. I'll just change my tool. in this particular case, I have a tap here already, but this is not the right tap. So I'm just going to change this to, I can either do a copy of this, which I just did. I'm going to change this to a 6 millimeter M6 with a 1 millimeter pitch. I'll change my tip diameter to 4 millimeters. Just keep that exactly the way it is. And as far as my levels go, I'm going to change my drill depth to go only, not to the tip of the part, but rather only up until the circle over here, the very bottom of the full diameter over there. Note when I go into my technology, it's automatically set at tapping already. Run my simulation. You can see that the tap will go into each hole around the part exactly the way it's supposed to. Okay, basically here I've now finished the entire part. And that's basically it. So what we basically saw in this is we set up the entire part, including the fixture. We did HSR to take care of all the excess roughing material that we had on the part. Most of the part in the pocket area and the very outside was done using regular 2.5D operations. We even did a shape tool to do this area using the profile operation, and we finished this off using HSS to get those areas that were not able to be done using your 2.5D operations. Now, there are some more questions over here. Is there any possibility to choose the whole chain, edge, start, and end continuous instead of choosing each end separately? In this particular case over here, sometimes there is what we're at it, the way you know right now, the simple way of doing it, you can't do that. However, we are working now, by the way, on a new option for creating chains, which can completely revolutionize it, that will allow us to easily pick the chains a lot easier than we're doing now. What I can do, however, let me just go into the operation, see if I can actually do this correctly over here. I'll go back into this HSS operation over here. Let me look at my geometries. And I'm going to pick this geometry a little different. Let me see if it works over here. I'm going to go to what we call multi-chain. And by multi-chain, I'm going to use the option of CAD selection. Now, sometimes if I do this correctly, if I right-click on this edge over here, I can say select tangency. If I do that, in this particular case, everything over here was tangent, so it allowed me to do it. If I do resume, I have my entire chain over there without picking each one individually. So that can be done also as well. But this was on the condition that all of these were tangent in this case. Even though it was not all on the same level, I was able to choose it this way as well. Okay. Now, there's been a question about feature recognition of the part itself, such as these tapped holes. We do not recognize yet the features of the tap holes, but again, that is something that we're actually I personally right now am actually working on something that will actually recognize features out of this SolidWorks features that are those if you created from the hole wizard. Something that was a tapped hole inside SolidWorks, we are working on actually being able to recognize it. This is something that will be done in the future. Always going deeper in the part, true, which is, you asked me about going deeper in the part. If you remember correctly, if I did this profile operation over here, I did mention that my levels, I have 35 millimeters, but I went further down by a 0.5 millimeter. Like you said, I want to go further down in the part. That's true. I can do the same thing with my HSR. Go a little further down. It's not a problem at all. However, again, if you do crash into the thing, it will crash into it. However, it will let you know that you've crashed into it. Okay? In other words, in fact, what I'll do is I'm going to do exactly what you told me, asked to do. I'm going to go down a delta of, let's say, minus 3 millimeters, which I know will go into the fixture itself. Okay, now, remember I told you about going past the depth? It tells me depth is below the coordinate system lower level. It warned me that I'm going past the depth. I can continue, no problem. It's up to me. I'm continuing, it's going past the depth, no problem. I'm letting it go past the depth. Okay? Now, okay, now remember the fixture is not part of the part yet. Let me go into the simulation itself. Let me do solid verify. Okay, now what we are working now, you'll note, there we go, it's crashed into the thing, but it lets us know that we crashed. We are, however, working on also adding another feature over here of also recognizing the fixture to tell it to avoid crashing into the fixture itself. It's not there yet, but we are working on that as well. In HSS, you can do that. You can tell it to avoid that. Okay. You can just continue, but you do see the crash. It did crash in there, but it did warn you about it. Okay. Okay. I see my time is also running out. The webinar will be available on our website. If I were to open up our website, and you go into our webinars area, we have webinar recordings. This webinar has been recorded. You'll find it over here, just like my previous webinars. It will be up tomorrow, and you'll be able to watch it, stream it over here, or you'll be able to download the video as well as download the part that I use in the webinar. Okay, everyone, thank you very much for joining us in the webinar. And have a great day. And since it's close to the weekend, have a great weekend as well.